Well, welcome everyone. This is COS 211, a lap around the entire Windows Azure platform. Going to try and get through a fair bit at a reasonably high level today. Just want to make it clear the right session, just in case you're expecting something else. If you want to get up and leave now, that'll be okay. If you want to get up and leave later, I'll be a little bit disappointed. So my name's Stephen Nagy. I'm a senior consultant with a company called Redify, and I'm a Windows Azure MVP. You can follow me on Twitter @Snaggy, and feel free to be as critical as you like on there. That's what Twitter's for, right? That's the hashtag for this session. If you want to be a bit more constructive with your feedback, make sure you get into the evals online and you know, give me a good rating of straight 9s. It'd be really nice. So we're here to talk about the Windows Azure platform. And the Windows Azure platform is pretty much, I like to think of it as an umbrella term for a whole bunch of different services. You know, Microsoft's kind of branding Windows Azure as their cloud offering. But really when we take a bit of a look at the platform in a minute, we'll see there's quite a variety of different features that we can use, some of them cloud-based, some of them useful for on-premise applications. And so while we have this umbrella term, it's very easy to sort of get wrapped up that the Azure platform is all about the cloud, when in fact it's not. It's very useful to help us build cloud applications, and that's the primary focus. But hopefully you'll see that there's a lot more to it than just utility computing, cloud computing, and those sorts of things. I wanted to actually start with a bit of a survey first. I just wanted to find out who here is already building stuff on the Windows Azure platform or has maybe an application on the platform now. Okay, so we've got a couple. That's cool. So you guys might be a little bit bored for the first few slides. And who's looking to move to the platform? Who's got maybe some legacy applications they'd like to port over, or perhaps they have a new product in development? I'll see a show of hands there as well. All right, fair few more. There's still probably 50% haven't put their hand up yet. So what are the rest of you guys here for? Sorry? Just to find out? Just to find out what it's about? That's cool. That's cool. All right, so of the other 50%, who's here just to find out? That's all it is, so that's good. Cool, all right, well, hopefully you'll have a good idea of what the platform's about at the end of this talk, and then maybe you'll go away and have a look, and maybe you'll find that there are some things that you've already got in your enterprises at the moment that might be suitable for the platform. So under the Windows Azure umbrella, we have quite a number of features. They're kind of listed off here at a high level. There's lots more lower level and granular things as well that we come across when we start developing with the platform and building things. Some of the features are in beta and CTP still. I'll still be going through those today. A lot of the beta and CTP things you can apply for through the Windows Azure portal, and some of them are actually closed at the moment. I'll talk about those when we get there. And I'm going to go through each one of these features at a reasonably high level, just so you've got an idea of what the entire platform's about. This is a non-technical talk. I'm not going to be showing any code. I'm trying to target this so that decision makers and infrastructure professionals, DBAs and developers all have an idea of what this platform's about and how they might be able to use it. I'd like to get a bit of a show of hands though, again. So who would say that they fall into that first bracket of maybe like a senior architect or decision maker, manager perhaps, something like that? Okay, fair chunky, that's cool. And maybe IT pro, infrastructure, system admin kind of role. Another about the same number again. DBAs. Got a couple, that's good. And developers. Developers win by the looks of it, maybe just. That's a really good mix though, that's a really good mix. So as I go through each of the features, you can see these little icons here like the arc, ARC in a circle. I'm going to have these little icons in the bottom right hand corner of the slides, and that will give you an idea. Perhaps if you're a DBA and you don't see the DBA icon, you might be able to close your eyes for that feature and have a little bit of a snooze. You're more than welcome to. All right, so let's get into it. So I'm going to start off by talking about Windows Azure Compute. Now, this is pretty much what everyone thinks about when they talk about the cloud and the Windows Azure platform. This is the raw computing power aspect. This is, I have an application I want to host in the cloud. I want to have it distributed and load balanced and, you know, scalable and all those cool cloudy things. This is really the representation of platform as a service, and I'll talk about why we call it platform as a service in a second. We have this concept of web roles and worker roles. Okay, so web roles are anything that's going to be public facing, respond to request response type models, so you know, web applications, and MVC and things like that, but also services. It even supports, you know, non-Microsoft web servers like Tomcat and Node.js, those sorts of things. So they're trying to make it quite cross-platform and, you know, able to support, you know, as many different languages and environments as possible. It does run on Windows Server under the hood, so it still has to be something that will run on a Microsoft operating system. It's completely config driven. And I guess what I mean by this is if you look at some of the other players in the space like Amazon and GoGrid and Rackspace and so on, those guys are really infrastructure as a service, because while you get to provision machines on demand as you need them, you're still responsible for those machines. You have to configure them, you have to patch them, setting up LANs and things like that. There's still a lot of responsibility on you to do a lot of that work. With Windows Azure Platform, you basically have an XML configuration file that states how you'd like to configure everything. What your CNAME alias is going to be, you know, how many instances of your web application, you know, how many VMs do you want running your web application, and you know, have it load balanced and things like that. And you just specify it in a configuration file, and that's it. And the platform takes care of the rest. You upload this configuration file along with your application. Azure will deploy your application as per how you've defined it in that configuration file across multiple machines, you know, across multiple containers to ensure good redundancy of your application. So a lot of smarts under the hood with the Windows Azure platform. They make sure that you're not going to get into a position where a hardware failure at one point is going to be a central point of failure and cause your application to be unavailable. Which kind of gets me on to the next point there. The deployments are automated, as I said, and failover is automated as well. So if your application crashes, or if the operating system crashes on the VM that it's running, or the hardware has a failure, the Windows Azure platform will automatically redeploy your application elsewhere in the data center to make sure that it stays up and running. And because they can do that, they offer a 99.99% SLA uptime. So everything's completely automated. Anything that you can think of that you might be able to automate when it comes to the infrastructure side of things, they've done it in the Azure platform. You can choose VM sizes from 1 to 8 cores, so 1, 2, 4, and 8. And there's an extra small instance now as well, which is, it's 1 core, but it's a smaller speed processor. Everything's managed by Microsoft. They'll do the patches to the machines, okay? Sometimes they may bring them down to do those patches, which is something you need to be wary of. You need to build your applications in a way that where they're running is stateless. You want to store your state elsewhere, maybe in database, in table storage, which I'll talk about in a minute, and so on. But it's a good idea to think about when you're building applications for the platform, is trying to make them as stateless as possible. And you get some added advantages by doing that as well, because it helps you build more scalable applications. There are 6 data centers around the world at the moment hosting Windows Azure. We've got 2 in the US, North and South Central US, Dublin, Amsterdam, Hong Kong and Singapore. So none in Australia, and not likely to be any in Australia in the near future. So that's compute. That's what most people think about when they start talking Windows Azure. They're talking about the cloudy aspect, cloud computing, utility computing, the scale out factor. That's kind of the core thing. And then everything else is kind of an extra service that we can start to use with that core compute aspect, or perhaps with other applications that are hosted elsewhere. Storage. So we have this concept of Windows Azure storage, and there are 3 types of storage that we can utilize. We have tables, blobs, and queues. Now, storage is designed to be extremely fast, quick response, and very scalable. Tables, you can think of them as kind of like a denormalized, non-relational data store. It's, if you have objects maybe, and this is maybe a bit of .NET speak here for a second for the devs, but if you have objects that you serialize If you imagine serializing that object as XML and sticking it in like a key value store, that's kind of what this is about, the table store. In a single table, we can store objects with different schemas. So it's not quite a graph database, it's not a document database, but it's kind of similar. We have an index, we have an object that goes in at that index. So it's a good solution for non-relational data because it's a lot cheaper than the hosted database offering, which I'll talk about in a minute. Blobs, binary large objects, staticky things like HTML, JavaScript, CSS, images, movies, music, PDFs, docs, all those kinds of things. Really useful sticking those in blob storage. You can have those in your web application that are uploaded in the web role in the compute thing that I talked about before. But if you want to change something, like maybe you want to change your product disclosure agreement on your website, you have to re-upload your application to Azure again to get those changes. Whereas if you had it in Blob Store, it's very easy just to change that blob, keep it at the same location, your web app still works. So, and there's some other advantages to using blobs as well, which I'll talk about in a second in the next slide. The final thing is queues, and this is really, for those who are familiar with the queue programming construct of first in, first out, this is really what these are, kind of at an enterprise level, highly scalable, useful for distributing work. So you might have, I didn't talk too much about the worker role a second ago, but a worker role is good for like background work, things that need to happen in maybe batch tasks, maybe you want asynchronously sending emails off in the background, those sorts of things. So queues are really good for distributing work to worker roles because if you dequeue an item off of this queue and you start to process it and your machine crashes, the queue will automatically requeue that item after a certain timeout. So it's kind of got that guaranteed message delivery pattern going on. And the other thing is that if two applications go to request an item off a queue at the same time, they guarantee that that item will not, like the single item will not go to the same two instances. They're guaranteed to get different items off of the queue. So it's completely asynchronous and works completely well in parallel. So it's a really good mechanism for distributing work. Now everything in the storage, the tables, the blobs and the queues are all automatically 3 times redundant, at least 3 times redundant, Microsoft tells us. And that's for free, you don't pay extra for that. So as soon as you upload a blob, it's getting distributed to 2 other SANs inside of the data center. So you don't have to worry about, that backup aspect. We access everything in storage via a REST API, so HTTP GET, HTTP delete, HTTP post, and query string type parameters for querying, particularly the table store, because we can do queries against our table store. We can query for objects that might have an ID of 3 or an integer larger than 5 or something like that. It uses Atom as the format for the XML for the responses. For the developers, we don't have to worry about constructing those HTTP GET requests ourselves because there's an API there for us under Windows Azure .storage client. And if you look at the training kit for Windows Azure, there's lots of demos and samples on how to do that. We can actually alias our storage. So if we do have maybe that product disclosure agreement inside of the blob store, if someone was to view source on our web page, we don't want them to see some Microsoft address there for the location of the blob. So we can put our own CNAME on that. We can have stevesapp.com/blobs/ product disclosure agreement. And again, the storage is available in the same 6 data centers that I spoke about previously. Okay, content delivery network. Microsoft's been building their own content delivery network now for like about the last 9 years or so. They used to rely heavily on Akamai and Limelight, and still do for a lot of things. But now they're actually putting their own servers into colo spaces around the world. And we're talking about 24 locations around the world at the moment. The CDN is an extension onto the blob storage. So when you create the storage account in the Azure platform, in the portal, you can basically tick a box that says, I want to enable CDN. And this will now allow all your blobs to be moved closer to your users. And this is useful, particularly for us here in Australia, because we have no data center here, but we do have a CDN endpoint in Sydney. The CDN is now supporting Silverlight smooth streaming. It's in CTP. You can jump on and play around with that at the moment if you're into the video stuff. 24 locations, as I said. Another good thing about the CDN and the blob storage I was saying before is that it does remove the traffic off of your web role. So it allows your web roles and your web applications to focus more on that application processing aspect and not serving up static data all the time. So for many, it's a good architectural decision to look at the blob storage and the CDN. And again, you can actually CNAME the CDN endpoint, so you don't get the really crappy Microsoft URL inside of your view source. Give you a quick idea of where all those locations are. Azure is fairly focused in the US at the moment. There's 2 data centers there, obviously, and a ton of CDN endpoints, and Europe as well. And Asia gets a little bit of a look in as well. Okay, the database aspect. So you'll hear this as being referred to as SQL Azure. And this has been around since the original sort of CTP release of the Windows Azure platform about 3 years ago. It is databases on demand, so we call this database as a service. It is a multi-tenant service, so that means your database is sitting on a server with other people's databases. And you can't see them. I don't know about you guys, I've used many shared hosts over the years, and I've used SQL Server databases, and you crack open Enterprise Manager and you can actually see everyone else's databases in the list there who are on the same server. Normally you can't access them. Sometimes you can. I often try to see if I can. You don't have that problem here in SQL Azure, okay? It's secure by default. In fact, it's locked down IP-wise by default. So you need to basically go into the portal and say, I'd like to allow this IP address to be able to access my database. So it's quite secure. You can then create your own additional users and roles through the SQL script that you would normally to do that. There's also a management console for it on the actual portal. And you can use Enterprise Manager for SQL Server 2008 R2 as well, but it's not that flashy yet. You don't get all the normal table designers and things like that. So when I'm building a new database for SQL Azure, I typically build it against my local SQL Express database first, build the scripts out, and then export the scripts and run them against SQL Azure. It is SQL Server 2008 under the hood. Okay, it's been forked. They've cut out a lot of things for security reasons to make sure people can't get across into each other's databases. One of the main things there is being able to run .NET code in SQL. Okay, so you can do that in SQL 2008, I think 2005 as well. You can't do that in SQL Azure. It is automatically 3 times redundant. Okay, so we don't have any concept of replication with SQL Azure, but Microsoft guarantees that your database is going to be at least 3 times redundant. So replicated at least twice under the hood. And it's kind of funny, the address that you get to talk to your database is actually just a logical address. And if there's a hardware failure under the hood, and for some reason one of your database is on one of the nodes that goes down, then that logical address just changes the IP address that it points to under the hood and points you off to the other database. So it's seamless to you. If there's a hardware failure, your app just continues working, talking to the database as if nothing's happened. There is this concept of a throttle. Because this is a multi-tenant database, you can't have extremely long-running queries that will starve the machine of resources, because then you'll be taking away from the other users that are on that same database. The throttles, it's around a couple of minutes, so you might want to think about that when you're architecting your applications for the platform, rather than maybe putting a whole bunch of work into a stored procedure that sits there and churns for like an hour and spits out, a whole bunch of genetic information. If you really want to do genetic programming in SQL, it's something to think about anyway. We've now got reporting services up there as well. You'll see this branded on the website as business intelligence, in fact. I personally don't think just reporting against a database means you have business intelligence. I believe it's more about data warehousing and data mining and those sorts of things. But that's how it's being branded at the moment. It's in CTP, so it's actually closed CTP at the moment as well, so you can't actually sign up and test it right now. But if there's anyone in the audience who's really, really eager to do so, let me know, because a direct mail to the team will normally get you an invite. It is the same as reporting services, if you're familiar with that already on SQL. And you can use the existing BI toolkit to build those RDL files and upload them and run them in the cloud, essentially. So it's pretty much everything you're already familiar with reporting services. You can only get your reports through HTTP requests. So that'll usually be embedded in your application somehow. The underlying reporting structure will scale out if it comes under heavy load. So this is all abstracted and hidden away from you guys, but it kind of guarantees that your reports are never going to suddenly slow down because something else is, spiking the machine. We don't have some of the features of reporting services like email delivery. Okay, this is purely HTTP requests to get the report, and we don't have the scheduled delivery and all those kinds of features that we like to have those automated reports sent out to the managers once a week and so on. The other thing is that it doesn't use Windows authentication like reporting services does. It uses the SQL Azure authentication. It's basically in-database authentication. So that's under CTP at the moment. As I said, let me know if you've got some interest in playing around with it. Okay, virtual machines. So I've kind of been banding on a little bit about platform as a service. Everything's abstracted away. Don't store state on your machines and things like that. There comes a time when we have applications that have dependencies that are a little bit more complex to install than on our existing web roles and worker roles. I'll give you an example of an application I know of. Company had a whole bunch of IP and calculations built into MATLAB, and they didn't want to go and rewrite all of that into .NET. So they wanted to deploy to Azure, and they wanted to deploy with MATLAB installed onto their machine instances. So this is where the virtual machine or the VM role comes in really, really handy. You get to build your own virtual machine, okay, based off of Windows Server 2008 R2. Install anything you like on there. You upload that virtual machine, and then when your application gets deployed, it gets deployed to that virtual machine rather than the existing web role or worker role virtual machine. This helps overcome any dependency problems you might have in moving your application up to the cloud. Now, you're responsible for that VM. So there's going to be no patching by Microsoft. Okay, so you've still got to take responsibility there. This is why you infrastructure guys are still going to be really, really important with the cloud. Someone's going to take responsibility for that because developers aren't going to worry about patching machines, right? This is not infrastructure as a service, though. The reason being is that the state for the virtual machines is not persisted. So if there's a hardware failure and that virtual machine goes down, where you've got your application deployed on a VM role, they're going to redeploy the VM role again elsewhere and deploy your application on top of it. Any state that was on that virtual machine is gone. So you still have to think about building stateless applications at the end of the day. So someone came to me and said, SQL Azure doesn't let me do .NET code in the database. I'd like to be able to do that. Could I install SQL Server on a VM role? Well, yes, you could. And your database might sit there and run happily for 6 months, and you'll build up a ton of data on there. And then one day something's going to happen and there's going to be a fault, and it's going to redeploy that fresh, empty database and SQL Server instance elsewhere, and you're going to have no data. So you still need to keep in mind that there's no state being persisted. Microsoft's not interested in being infrastructure as a service provider. They're purely about the platform aspect. Service bus. So this is a messaging construct. It's about having a stable endpoint in the cloud for your services on premise. So I guess I'll try and illustrate with this with a bit of an example. If you think about maybe you've got an internal application that the CEO likes to use. He might use a Windows Forms app, and it talks to a service layer under the hood internally. And that all works fine and dandy. And then when he goes home at night, he wants to use that app on his home internet connection. Well, he can't, right? Because the services are internal to your organisation. They're not on a public IP address. There's going to be no port forwarding going on. Okay, it's non-contactable. He talks to the infrastructure guys and says, I want you to make it contactable. I want to be able to access this thing from home. And they say, well, no, that violates our security policy. We don't want to start opening up all these ports, and we certainly don't want to be putting that server on a public IP address. It'll be targetable, and so on and so on. So what the relay does in this scenario is allow us to have the endpoint being in the cloud. So the application, that Windows application, only knows about this endpoint in the cloud. That's where it talks to for its services. That endpoint then talks down to the services on premise. Now you might think, well, that's still the same problem, right? How's it going to talk down to the services on premise? Well, what actually happens is when you run your services on premise, rather than them listening for incoming requests, it actually opens up an outbound request to the cloud. So it goes, I know I can't be contacted, but I can call out to the web. I'm going to call out to the cloud, to Azure, and I'm going to open up a TCP socket, and I'm going to keep it open permanently. And then when any application makes a request to that relay in the cloud, it just comes down that open socket. So this is how it's able to kind of punch a hole through the firewall, because it's an outbound connection rather than receiving inbound requests. Now, if you don't have any outbound connections from your servers as well, then yeah, that's going to be a problem. But I can tell you, I've done a lot of TFS consulting in my time, and I've installed a lot of applications on servers, and I've been always able to hit the internet on those servers. Sure, I have to click on add to trust this site 100,000 times, but I can always access the internet from servers. Maybe not the DC, but most of the other servers I can. So I would dare say most people's organisations, this is actually going to work for you being able to expose services outside of your organisation. Now, one of the things it can do is, if that CEO comes into work again the next day and he's using that app again and he's internal to the network, there's no point him constantly communicating via that relay in the cloud back down into the same organisation. So what the service bus will do is try and broker a direct connection. If it sees that the client and the service are actually able to talk to each other directly with no restriction, then it will tell them to do so. And so you will no longer be going up by the relay, which means you won't be paying the cost of using the relay as well, which is a good thing. There is some BizTalk integration, and for the developers who use WCF, it's basically another set of WCF bindings, essentially, just to make this work. So you install the Windows Azure App Fabric toolkit, and that will give you some additional bindings that you can use, and that will let you use the relay straight away. You need to have an Azure account as well. Access control. This is quite a deep and complex area. I might just get a quick show of hands actually. Who knows or who has a basic understanding of claims-based authentication? Okay, so maybe a quarter of you guys. I don't want to go into it now. It's not a Microsoft specific thing. It's basically an inversion of the way we can do authentication and authorization, rather than people coming to our website, logging in, tracking the session through a cookie and all those sorts of things. It's about flipping it around and the website saying, if this user comes to me and says they're an admin, I'm just going to trust that they're an admin. But it can do that because when it comes to them and gives them the token that says them an admin, that token's been signed by a third-party trusted provider. And that's what the access control service does here. It's that third-party provider. The interesting thing about that is that the access control service can then branch out and take authentication from other sources, such as Facebook, Live, Yahoo, Google. But if you're not building fun little apps, something more interesting is that Active Directory. So if you have ADFS version 2 installed for your Active Directory, that exposes a secure token service for your Active Directory out to the internet so people can authenticate. The access control services can talk to that, and then when users come to your website that might be running up in the cloud on the web role and something like that, they can actually log in using your AD credentials. So this starts to give us that single sign-on scenario. It allows us to actually federate multiple identities as well. Think about, let's say I build an application and I want anyone from my Active Directory to be able to get in and use the app and maybe use administrative type features or maybe power user type features. But I've also got suppliers who are exposing this STS as well. I want them to be able to log into my website as well. But when they log in, they're going to get a restricted supplier portal where they can register maybe the products that they're going to sell. So I can actually do that. So this is what the Access Control Services lets me do. It will aggregate from multiple different identity providers and allow those providers to authenticate to my application. I get to control who I'm going to let in. I get to control what they can do once they get in. There's a whole lot of stuff around iClaimable identity or iClaim identity for the .NET devs. And it's very well published. If you look at the Windows Identity Foundation stuff, there's a lot of information there about claims and how to use it in .NET. And if you're looking down the access control path, then yeah, you'll need to check that stuff out. So it's just this identity aggregator at the end of the day. You still need to have that understanding of claims-based authentication, and your application still needs to use claims-based authentication, obviously. Any questions so far? We've kind of driving through them fairly quickly. Yes? You might have to speak up a little bit. I can't hear you so well. Dynamic SQL. Remind me what dynamic SQL is again.
Say if I'm having a search parameter from a web application where I'm just passing the SQL queries.
You can still execute. It's SQL Azure is just like SQL Server at the end of the day. You open up a connection, and in fact it looks exactly the same. It uses the tabular data stream protocol under the hood, the same thing that SQL Server uses. You can just open up, if you want to do a direct string with a query in it, construct that query and just execute it against the database, you can do so. It's exactly the same as SQL Server. Yeah. There is question time at the end as well if you guys feel like holding off, or I'm available for a chat afterwards as well if you've got some more in-depth questions. Caching. So this is the manifestation of the codename Velocity product from Microsoft, which was built into Windows Server App Fabric and is now into Windows Azure App Fabric. It's basically a purely in-memory cache that you can use on demand. Highly scalable, very performant, very fast, and very easy to use. We've got a number of different cache sizes we can choose from, and we pay, I think we're looking in order of starting at about $40 a month for the 128 meg, and scaling up uniformly based on those numbers. It is basically capped at that amount that you've specified. So if you keep putting more items into the cache and you exceed that quota, it's going to delete the least recently used item out of the cache to make space for stuff going in. It's very easy to use if you're using session state and ASP.NET Cache already. It's web config changes to use it. You need to install the provider, which is from the toolkit, but then it's just a matter of configuring it to turn it on. And if you're familiar with sticking session state in SQL database, then you'll know that your stuff that you're putting in needs to be serializable. It's the same thing here. You need to make sure the stuff that you're putting in is serializable. Very easy to use, not much more to it than that, but just highly performant, good place to store computations so you don't have to recalculate them. You don't want to have those things sitting on your web roles again because of that whole, we don't want to keep state there, okay? So this is a good place to put that stuff. Guarantees that it's going to be available to all of your web role instances. Anyone can grab that data and use it and read and write from it. So fairly simple concept, not too much to explain there. Okay, some more for the infrastructure guys. Connect. Windows Azure Connect, not Xbox 360 Connect. That's the other session down the hall. Is a way that you can create a secure connection between one of your machines that are on-premise and those web roles, worker roles, VM roles, and so on, sitting up in Windows Azure. So it creates a secure connection between the two. It's like a private network. They see each other as if they're on a LAN, okay, if they're on the same IP address range. It's as easy as basically installing a little agent on the local machine that's on premise, and then configuring it through the portal and saying who it can talk to and you know, what's made up of that little network, essentially. And this opens up a number of possibilities to us. So for example, if I was to say put it on one of my domain controllers and then connect that to, you know, my web roles, I can now domain join my web roles to my domain that's on premise, and that will now allow me to do Windows authentication, you know, AD authentication to my application. So that this is like an alternative to the STS scenario that I was talking about before with ACS, with the access control services. So I don't have to install ADFS v2 to expose my domain. I could instead use this concept. There's no emailing service in Windows Azure, and it doesn't look like there's going to be anything anytime soon. We do have BPOS, Office 365, and you know, there's some integration there for sending mail, but at the moment, if you want to send email from your applications running in Azure, you've got to use something outside of Windows Azure to do that. A lot of people already have SMTP servers, and they're not going to be going away anytime soon. So perhaps you could use your own SMTP server at least, and that will help you avoid, you know, maybe blacklisting from, you know, the more heavily used spam bot type mail services. You want to transfer data back and forward, and you want it to be encrypted. Don't want to have to worry about that encryption yourself. Okay, you could do that here. Maybe you've got a database that's on premise at the moment that you don't want to move up to the cloud because you're worried about, you know, all the hype around data in the cloud and, you know, Patriot Acts and all these funny things. Worry about people stealing your data. You can keep it on premise and, you know, connect to it using this particular technology and expose that up to your web roles or worker roles up in the cloud. So this is something obviously that infrastructure guys are going to need to approve to install the agent on their machine to allow for this to happen. So it's, you know, they have to be heavily involved in that discussion, obviously. It's under CTP at the moment, but it is, anyone can sign up to it and play around with it. You can install it on your laptop and, you know, securely connect your laptop up to a web role in Azure if you want to, just for fun. Traffic Manager. This one's a little bit of a niche concept. Who here would say that they've got a pretty large web application, you know, serving a lot of people? We've got a few. Okay, so you guys might be interested about this. Who here has redundancy, like multiple data centers, applications deployed in more than one location in case of acts of God, natural disasters, those sorts of things? There's a few as well. Okay. So how many of you, just put your hand up, actually test that regularly? A few, that's good. That's good. When we want to be able to switch from pointing from one data center to another, you know, maybe because that we're testing, or maybe we've got that worst case scenario where this data center has been blown off the face of the earth for some reason. We want our apps running elsewhere, we want them up and available, and we want it to be able to respond immediately. It'd be really nice if our application, we've deployed it to 2 data centers. Maybe we've deployed it to the Singapore data center for Azure. We've also deployed it to, say, Amsterdam. And Singapore's our main one, and all our requests and users are interacting with the Singapore one. And something happens and, you know, maybe there's a coup, or maybe just for some reason the main pipe connection into the Singapore data center dies and everything there is now unavailable. Or maybe your app just crashes there for some reason. We want users, we want to be able to continue business as usual. And there's a lot of high transactional websites in Australia who are looking at this now, who have these big DR sites distributed across, you know, Australia just because they can't afford to have any downtime. Traffic Manager is basically a technology that will route traffic you know, to one location. Until that location becomes unresponsive, we can then route traffic to another location. and it takes care of that through IP address, through name resolution essentially. It's got 3 modes. It's got the failover mode, which I just talked about. It's got performance mode, so if you've got your app deployed to maybe all 6 of the data centers, user comes in from England to use your application, it'll get directed to the closest one, latency-wise, which would be Ireland. Okay, so that's performance. And the third option is round robin. You just want every request round robins between data centers. I can't think of a really good use case for that personally, but it's there as an option. Now, the way it works is it doesn't actually, it's not the choke point for traffic, okay? It's not like all traffic is constantly going through the traffic manager. Instead, it just does name resolution and specifies time to live. So if someone comes in looking for stevesapp.com, that goes to the traffic manager for the lookup. And the traffic manager goes, all right, well, Steve just came from Australia. The closest data center latency-wise, who wants to take a guess at what the closest data center is latency-wise? Singapore? It's the closest physically. The closest latency is actually South Central US. Not sure why that is, but if you run some tests up, you'll see that you'll get better speeds out of South Central US in most cases. There's a few periods of the day when it'll be faster out of Singapore. So it goes, Steve's closest to South Central US, so I'm going to give him the IP address for that data center and a time to live of 10 minutes. Now, you as the owner of the app, you can specify that time to live. So Steve goes off and he's hitting the South Central US data center for 10 minutes, and in that 10 minutes, someone comes in and takes out that data center. For some reason, it disappears off the face of the earth. After 10 minutes is up, Steve's going to come back. I probably should be pressing the buttons here. Steve comes back and he requests again for stevesapp.com. And it basically says, all right, well, I can no longer ping that server anymore. I can no longer get to your application running in that data center. So I'm going to give you an IP address pointing to another data center, and you'll continue to interact with that one for the next 10 minutes. So the time to live is really important. If you're using this for failover in particular, if you're using this for performance, the time to live can be a day, a week if you really wanted it to be, because they're not going to move, it's unlikely they're going to move from England to Australia, and you then want to have it recalculate every 5 minutes what their closest location is going to be, because there is time taken to do a name lookup. Okay, there's a little bit of lag to do a name lookup in general. So it depends what you want to use this for, but if you've got, if you need that redundancy scenario and you're worried about a single data center being a point of failure, then you'll be interested in using the traffic manager for routing your traffic. I am a little bit ahead of schedule. A lot ahead of schedule. And we're on the last feature, the marketplace. So the marketplace is every good platform has a marketplace, right? It's a good place for you to actually register your Azure application to be discovered and found if you want to use it for that. It's a good place to obviously find Azure applications. But it's also a data market. And I think this is where it's getting more of its use at the moment and most of its popularity. So if you've got a set of data that you'd like to expose to the web, maybe on a subscription-based fee, you want to charge people monthly for using your data, you can use the marketplace for that. If you want to use data, if you want to find maybe postcode lookups or phone number lookups or some of these sorts of things, you can actually do so. Here's actually an example of some of the data markets available. So we have environmental information for US zip codes, travel, advisory service. Now these things cost. I've seen some of these cost anywhere from $50 to a month to $1,000 a month. It depends on the data and how important that data is, I guess. But if you're building applications, you might want to make use of some of these sorts of things. It's a good central hub for finding data for your applications. Normally you've got to search around. If you want to do like a UK postcode search, you go find a particular service in the UK that might do that. You end up with lots of different services from lots of different locations. There's a whole lot of APIs around this that makes it discoverable and searchable. You can do it all from the web, but you can also do it from programming interface as well. So it's there if you want to use it. It's relatively new. So, we've all got a lot to learn by the looks of it. Our decision makers, our IT pros, developers and DBAs. There's something there for everyone. Probably the best way to actually now go on and find out a little bit more is there's lots of sessions here at TechEd, obviously. There's about 13 or 14 sessions in the cloud track, cloud and online services. So go check some of those. Anything that says that's got Azure in the name, if it's App Fabric, then it's going to be related to the service bus, the access control, and the caching. If it says SQL Azure, it's obviously going to be about SQL Azure, the database or the reporting stuff. So check those out. If you go to the Windows Azure homepage, there is a feature list that uses all these icons here, and you'll be able to go through and read a bit more detail, follow through into white papers and find out a bit more as well. I'm here for all week, so if you see me around, I'm happy to have those hallway discussions and find out what you might be interested in using the platform for or any problems you might come up against. If you are banging your head against a wall for some things with the platform, again, come and talk to me because I might be able to get you a more direct route to the product team to solve some of those problems. If you want to know more about me, you can just hit my blog. Email address is there if you want to email me any questions afterwards. You've got Twitter if you want to contact me on there as well. Happy to hear it. And I might use that to close up for now, and I might open up to any questions.
Can you set up a Windows cluster in the cloud that's using virtual machines?
Can you set up a Windows cluster? So you can, with the virtual machine, set up a DC if you wanted to, but you still have to keep in mind of the whole stateful aspect of things. So if that DC goes down and gets redeployed again from elsewhere, you have to think about the implications for that. Now, I'm not an expert on building Windows clusters, and I don't know what it actually takes. I'm not sure how much that state needs to be persisted, but if you don't think there's any at all, then I'm sure there's no reason why it wouldn't work. Yeah. How do you answer the question, is it really secure? I try and not answer that question. How would I? Look, we saw what happened recently with, was it Sony? 1 million credit cards hacked, something like that. We saw Amazon go down for, one of their data centers go down for 2 days or something like that. I guess the question is, how secure is your data center now? Because one of the biggest threats to security is actually physical in-person security. It's physical access to boxes and things like that. Now, Microsoft are some of the best engineers in the world working in those data centers. I was over in Seattle earlier this year, and I tried to get into a data center, and they wouldn't let me in. They wouldn't let me do a tour. They were going to charge me $1,500 so that I would have 2 security guards next to me for the data center tour. So when it comes to physical security, Microsoft have it. Okay, they've got armed guards walking around. They make sure that no one's getting into those data centers. Now, I don't know how many of you guys have armed guards for your data centers. So physical security, they win by far. They've got the smartest engineers working in their data centers to make sure that they're actually secure. But it's only going to be as secure as the operating system at the end of the day. So any thoughts that you have around security relating to Windows, those apply for if you're running Windows in the cloud, on-premise, wherever that's going to be. They're secure. When I say they're secure by default, like with the SQL Azure stuff, that's a term that basically indicates it's locked down. You have to take steps to make it less secure, to expose it to your applications. So I don't know if that. I mean, it's very difficult to say something's secure. It's a how do you measure that? Oh, where I'm 100% secure. Tick. Yeah. So using the Connect. That uses IPsec for point-to-point security. So it's as secure as the IPsec protocol, which should be fairly well documented on the interwebs. He's got the microphone.
How can we find out?
I don't think the microphone's turned on.
Okay. How can we find out if there are any compliance that we need? Say, for example, storing credit card information or medical records?
That's a good question. So there is no PCI compliance within any of the Azure data centers because PCI compliance applies to not just the infrastructure, but also the applications that run on the operating system. So they do not give PCI compliance. However, there are actually companies now that offer PCI compliance as a service. You can use a lot of the merchant services around who will actually store parts of a credit card so that you can store the other part, okay, and they're PCI compliant. So you can kind of get that as a remote service, but you'll not get a lot of compliance in a lot of the cloud providers because a lot of these compliances and standards actually apply to both physical and software. So the infrastructure and the software, the operating system and all those sorts of things that sit on top of it as well. So Microsoft, they have some certifications. They're not even going to go for PCI. They're not going to go for a lot of the big ones that most people will be asking. And it's the same with Amazon and Rackspace and those guys.
Talk a lot about security and about federation and everything, claim-based verification.
Yep.
With the web portal access, so you have a live ID and a single password, is that going to change? You have to make that a more secure way to manage what could be verified instances.
Yeah, so the question was about accessing the portal. Currently, there's only one live ID that gets assigned as the owner to a subscription for Azure. And how do you how do you give that to your infrastructure guys to manage the CNAMEs for the aliases, or how do you give it to the developers so that they can do uploads of the application to the portal and these sorts of things? It's a good question. You can, for the Windows Azure Compute stuff, you can now assign multiple live IDs. But that's not available yet for the SQL Azure and for the App Fabric stuff. But it's coming, so we'll have that. When it comes to the database itself for SQL Azure, you have an administrator account for the database. You can then go in and create additional roles through standard SQL script. So you can create other users with the restricted permissions. That's not to the portal, obviously, but that's to the database. So you can still give DBAs just database access, at least. They are overhauling some of the security models, so I think that will definitely get better going forward. Sorry? Nothing I can talk about, yeah.
You spoke of latency and some tests that you've done. What sort of tests have you done to measure latency? And is Singapore the second fastest, or is there other places in the world that are faster than Singapore?
Yeah, so when it comes to testing the latency between locations and data centers, there's actually a ton of people who've already built apps and have running Azure applications in all 6 of the data centers that you can, it's kind of like my speed test, for your ADSL connection. They're already there, so you just use those, and they're the ones that will help you to determine which is your closest data center. And I've run those tests at various times of the day, and most of it's actually just through general usage. Like, I've been using the platform now for 3 years, and it's just, I've noticed it, I've talked to many people who've noticed it. Singapore is not the fastest. I don't have an exact order of which is, least to most fastest in terms of connecting from Australia, but generally we get faster speeds out of the US than we do out of Singapore. And Yorker, who works for DPE at Microsoft, he has an explanation for this, and I don't understand it, but if there's any IT pros here, want to find out, go talk to him, get the explanation, come back and explain it to me. I'd really appreciate that. But it's got something to do with the way the name servers get routed from Singapore out to Hong Kong and then back to Singapore and then down to Australia again, and something funky like that. And that's where the bottleneck is, to my understanding. Yeah. It's not like the network's slow there. They've got super fast bandwidth all through Eastern and Central Asia. Can I give you a quick promo of my next session? Well, I've only got one other session, and it's a group session with some other Redify guys, and it's about building a multiplayer phone application and using Azure as the back end. The Azure part's actually quite small in this because we just loaded up a web role with some JSON services, and it just worked, and it was responsive and fast. So for the Azure aspect of that, it's not going to be huge if that's what you're going for. But if you're interested in the XNA and the Silverlight on the phone and HTML5 and all those sorts of things, then yeah, I suggest coming along.
Talk a bit about some of the challenges of moving traditional relational database applications to the cloud type data source.
Yeah, definitely. So the question was, what are some of the challenges around moving an existing relational based application up into the cloud? So let's say we have a web application with a SQL Server backend, and we heavily use the relational aspect of that. The first thing we want to do when we do a migration is, and by the way, there's actually a session on this at the moment. I think Mahesh is doing a talk on migrating applications to the cloud. I know he submitted, I can't remember if I got in, so have a check for that. But one of the first things you want to do is you want to get blobs out of the database, because SQL Azure is approximately 250 times more expensive per month than blob storage. Okay, you're looking at 15 cents per gig on blob storage, and you're looking at something like, depending on, for 1 gig, I think it's $10. So, you're paying for the relational aspect of that. There's no point putting non-relational constructs into that database. So blob data, you want to pull them out, put them into blob storage, and just store the URLs to the blob storage instead in your database. Next thing you might want to do is, quite often we log a lot of information to our databases. So you might track just a history of transactions. Sometimes we have tables that we just write to that we never read from, but they're there for logging purposes. Those things are really good for table storage. So get them out of there as well, because they end up getting really, really big. Quite often we end up truncating those, and there's no point chewing up our precious $10 per gig inside of the SQL database. Might as well get that out, stick that in somewhere like table storage. Things like link to SQL, entity framework, and all those sorts of things, they all work against SQL Azure. So there's not really anything to worry about there. And Hibernate works. They all just use the SQL protocols under the hood. So, and those things are still the same. So they all still work. Probably the only other thing you want to think about is, I know this is very simplistic anyway, but configuration. So when you have to change something about your application, if you change a web.config value, and you've got a web farm with your application, you've got to change it on the web config on every single machine. And if you forget one, you suddenly got these random bugs popping up that you can't quite nail down and work out, because they only kind of pop up intermittently. With Azure, we actually have a central configuration place that we can store stuff, where we can pull from that configuration from all of our web roles. So it's a good idea to think about what things you might want to pull into that configuration and put there. So probably the 3 starting points for migrating to the platform. If you've got something in particular with your app, we can maybe have a chat afterwards and have a talk about it. Any more questions? All right, well, thank you for coming along, and remember speaker evals. If you don't rate me highly, I don't come back next year. So thank you.